Alright, this is Unit 7, Lesson 7 of our calculus class. Unit 7 is Applications of Integration. Lesson 7, we're going to learn about disk method. So in this lesson, we're going to talk about what is disk method and how do you calculate it. Or how do you calculate volumes using disk method. So if we have a region bound by two curves, so we have a function f of x on top, and we're rotating this region around some horizontal axis, and we'll call that g of x, just some straight horizontal axis. This green region is going to get rotated to create some kind of solid shape. And in class, I took my little metal wire that I found, and I demonstrated what we're doing here. If I just take this metal wire and I spin it, what we do is we create the illusion of a three-dimensional object. And so if we rotate this thing horizontally, what we're going to get is kind of this circular shape. If I cut any vertical cross-section, each cross-section is going to be a circle. So to find the volume of this sponge shape, we're going to use what's called disk method. And if I take any cross-section, it's going to be just a circular disk. The area of that disk is pi r squared, and r being the height of the function. So if we're going from our function f to some function down here g, then the radius of each disk is going to be f of x minus g of x. So we can write up our integration using disk method as the volume of the area of x would be the volume of the integral of pi times radius, and radius is f of x minus g of x squared, and then times d of x. D of x would be the height of each of those disks in this case. And that's how we calculate the volume of such a shape. You may ask, why would we spin an object around a horizontal line? And I would ask you, why not? Here's an example. So if we put some equations to f of x and g of x, f of x is this line is x squared, and the axis of rotation, g of x, is y equals -2. So our area would be x squared minus -2, or x squared plus 2, would be the radius, which means our area would be pi times x squared plus 2 squared. And so if we integrate that area function from the intervals 0 to 2, because 0 to 2 is the lower and upper x value of the shaded region, we would get the volume of such a shape that is created by this region being rotated around the horizontal axis, y equals -2. So here's another example. If I take this f of x function, which is equal to the square root of 2x, and I rotate that around just the x-axis this time, we're going to get this kind of acorn-looking shape. The radius of this shape is f of x minus g of x. Since g of x is just the x-axis, we're taking f of x minus 0. So in this case, we can just put f of x, which makes it a lot easier. So the radius of our disks is the square root of 2x, which means the area is pi times the square root of 2x squared, or pi 2x. And so if we integrate this thing from x values 0 to 5, pi 2x dx, we're going to get the volume of this rotated shape. And that one we can integrate nicely by hand. It equals 25 pi. Alright, so that's the disk method in a nutshell, and that's how you use disk method to calculate the volume of a shape. In your assignment, the beginning and end points aren't necessarily clear whole numbers, so you do want to use your graphing feature on your graphing calculator, and you use there's a calculate button to find the intersection points, the beginning point and end point of where your two functions are going to intersect. If you need to use that for this one, go for it. You'll put your functions into the y equals window, and then you'll go for my calculator. Just pull that up. Once you have your equations graphed, I'll make a second video for that, but press second trace and that'll pull up the calculator feature, and then you can press the fifth function is intersect, and so you can use the intersect function straight on the graph to find intersection points that are accurate. And that's it for this lesson.